Signs of climate change are already visible in sensitive ecosystems. A team of Romanian researchers wants to understand what to expect in the near future. By comparing large amounts of data, they will quantify landform dynamics from various periods. This will help predict the imminent changes in the Carpathian Mountains and Danube Delta. These areas are hotspots for both geo and biodiversity. The goal of this project is to minimize the risk associated with climate change. Possible solutions and efficient management are the expected outcome. Stay tuned to understand how climate change will affect Romania's ecosystems.
What is the novelty that your project introduces?
So the novelty of the project comes from different sources. One of them is the approach of the landforms and geomorphological hazards, response to climate change and especially to climate extremes. And we are doing that at different time scales, at a short one like the last decades, but also at a longer time scale of several millennia after the last deglaciation, which involves around 20,000 years, and with a more focus on the Holocene period, when the climate became mild, like in the present, which covers more or less the last 11,000 years. So this is one of the novelty sources. And the other one, it is the fact that we are doing an uncommon compilation of different environments, like the mountains on one hand, and the coastal, low-lying and river deltas on the other side. And we are doing this because these are the most climate-sensitive environments from Romania. Danube Delta because it is impacted by the present sea level rise, while the Carpathians are warming at a faster rate than the other regions, like around 2 degrees in the last 40 years. So it's a lot, in fact.
How does the ClimaLand project integrate geochronology, remote sensing, climate monitoring and modeling to assess the impact of climate change and extreme natural phenomena on landforms dynamics?
So our study regions include several types of landforms and landscapes, and they react very differently to the climate variability and climate changes. And some of them, for instance, did not change too much in a century or even in 1,000 years, like a glacial valley. On the other side, there are the natural systems from the low-lying coasts and Danube Delta, which are transforming completely in this time span. So in order to get an integral view of how the natural systems react to climate change, you need to involve several types to use different scales of dynamics. And this is why we have a project dealing with so many and different landscapes. And this also requires multi-proxy analysis from, let's say, geochronology and geochemistry to sedimentology, geomorphology, climatology, natural hazard assessment, and of course, numerical modeling to assess the near future development in this kind of systems. Alpine lakes are pristine environments which capture very accurately the paleo-environment information, and this is very valuable in the paleoscience studies. That's why we also involved different lakes from the southern Carpathians in our area, and they are also good for the regional changes and also for the local ones. Are changes which are related sometimes to the a decline of a civilization, like in Neolithic or Bronze Age, or other time it's about the vegetation history or about the human colonization of the alpine environment, so different kind of systems. And that's why everywhere in the world the alpine lakes are very, very useful for paleoclimate and other different of paleoscience. Also, we in our project use the glacial lakes for reconstructing, for instance, the debris flows. And debris flows are one of the most important natural hazards affecting the mountains. And we could see exactly the layers using different types of analysis, but especially the geochemistry with an eye track scanning of the cores. We are in Orshova research station, this kind of machine, and we could see the layers which are more enriched in some chemical elements like titanium, iron, with a higher magnetic susceptibility. But for the other natural hazards from the alpine environment, like snow avalanche or like rockfall events, we are using other methodologies. For instance, we are using dendrochronology because the trees, the forest, records very very well the history of the snow avalanches, but at a smaller time scale. And also the cosmogenic nuclides method for dating the rockfall events, for instance. And we have a reconstruction already published for covering around 15,000 years using this method. And I should mention that the cosmogenic nuclide dating method was introduced in Romania with the help of this Norwegian project, because it was introduced by our partner at the National Institute of Physics and Engineering, Horia Hulubei, with some of our PhD students. And now we already dated around 200 new ages, which I think it is a technical performance also. And we have requests even from different countries to use this method in other parts of the world.
What are the preliminary results so far in your project?
Okay, so concerning the Black Sea coast and the Danube Delta, we already proved using drills like in this image, and also core-rings of different sizes for the recent sedimentation, but also a good database of monitoring of the shoreline behavior. So we proved that the Danube Delta coast is characterized by a centennial evolution governed by the river discharge. But very interesting, at a shorter time scale, like at a decadal time scales, the main principle of coast behavior is NAO, is North Atlantic Oscillation. So it's about the climate variability via storminess. The storms becomes much more important, and we could see that there are decades with shoreline evolution very rapid, and the others which are much slower. And this is completely related by the climate. So the climate makes the rule for this shorter time scale. And then, of course, we are very interested also to see what will happen in the near future. That's why we are using the sedimentation rates from the delta plane that we can capture using, for instance, lead-210 or cesium-137 isotopes for the short time span to introduce in different models. And here, with the help of our colleague Florin Zăinescu, we get some nice results, because it's the first time that a process-based modeling could reproduce an asymmetric wave influenced delta lobe like in the real delta. So now we can go back in the past to reconstruct the phases and to see what will happen in different scenarios also. And just a comparison of the present morphology and of the reconstructed using modeling for Sulina lobe in the past and for the present Sfântu Gheorghe. And very interesting, we have this sea level rise projection with sea level rise of between ½ meter and 1 meter till the end of this century, so will be a lot. And we used both scenarios, the, let's say, optimistic and pessimistic one, to assess how the delta plane will evolve. And in the first step, we used a smaller surface, an idealized Danube delta plane, and then Florin ruled these models, and we could see that significant parts of the Danube delta plane will be affected by the flooding. It's not just about the coast, it's also about the internal part of the delta, which is very depressed in terms of absolute altitude. It's below 1 meter above sea level. So the water level from delta plane being connected to the Black Sea, the impact will be even far away from the coast, with large surfaces which can be drowned, which can be covered by the water.
What are the next steps in your project?
In the present, in situ climatic monitoring is ongoing. We already made boreholes for monitoring permafrost, and we also installed a weather station and developed new hotspots for the cold environment research, like in this case in Făgăraș Mountains on the Doamnei Valley. And it's important because we succeeded to set up a long-term and continuous database connected to the European permafrost monitoring database, which was one of the main objectives of the project. So in the future, the follow-up step should be to think a new project to continue this one, trying to relate a sediment to source study, to relate the sediment flux between the Carpathians to the river valleys, to the Danube Delta into the Black Sea, and how this chain of sediments is affected by the climate and can sustain different kinds of natural systems in this, let's say, Carpathian Danube Black Sea macro system.
Working with a diverse team and collaborating internationally with esteemed institutions like University of Oslo, West University of Timișoara and Horia Hulubei National Institute of R&D in Physics and Nuclear Engineering, what advantages or benefits does this project bring to your project and team?
We benefited a lot because our partners are highly specialized in different thematic in different scientific directions. For instance, the West University of Timișoara is a reputed center for the mountain geomorphology in Romania in Southeast Europe, while the National Institute for Physics and Engineering, Horia Hulubei, was the best accommodation for applying this new method of cosmogenic nuclides dating of the rocks, but also to date by carbon-14, the lacustrine sediments, and also to make another analysis necessary for the project. But of course, our partners from the University of Oslo had the most important contribution because the team, which is led by Professor Bernd Etzelmüller, is one of the most reputed and very well cited, especially for the studies concerning permafrost and different kind of physical processes, applications and numerical modeling in cryosphere. And this was an excellent example of know-how transfer because we can do new and valuable studies together. For instance, we made a new permafrost modeling for the Southern Carpathians, like in this image. And very interesting, every year in summer and fall, our Norwegian colleagues came in Romania and we had many fieldworks together, even doing laser scanning for the rock walls or doing geophysics measurements. Here we also benefited by the help of the Ministry of Internal Affairs, which could help us with helicopter transport of the equipment in the Retezat and also in the Făgăraș for coring or for doing geophysical, and it was much easier. And also the results now can detect and map much better the permafrost distribution in these two massives, Făgăraș and Retezat, which are the key sites of our study. And more than that, their attitude, their very high involvement was an example for our team. And even last year, we also had a field trip in Norway and some workshops where we could discuss the data and also to see their network of boreholes monitoring permafrost and processes, which was very valuable for our team.
Can you discuss the envisaged solutions proposed by the ClimaLand project for the efficient management of risks associated with climate change and extreme natural phenomena?
First of all, we highlight in our project that we have different realities depending on the time scales. And landscapes and the landforms evolve differently. So we can now understand better and we can project more accurately the way this natural process evolves. This is one of the benefits. But looking at the natural hazards from the mountains, like debris flow, rock falls, snow avalanches, I think the main benefit it is that we can have a more accurate forecast and also develop natural hazard awareness, which we promote through our scientific papers. As we noticed, Danube Delta is threatened by the present sea level rise. Already the vegetation is changing in the last decades in the proximity of the coast. So the things are happening because the general water level in the Danube Delta is higher and higher from one year to another. So it's a clear problem that we addressed by modeling and present sedimentation rates assessment. But very interesting is that our paleogeographical reconstruction of the Danube Delta evolution, which was also supported by this project, proved that the modern Danube Delta knew in the past a similar episode of drowning. It happened in its early phase of development, somewhere between 7,000 and 5,000 years ago, when a large part of the delta plain was drowned by the giant lakes and lagoons covering the delta plain. So it's a clear proof that the things might happen again, and this is a real threat. And speaking about the measures that we propose, first of all, it's necessary a much more clever management of the sediments. So we need sediment for the coastal part. We need all the sediment that will be dredged in the reservoirs and dams on different tributaries of the Danube, but also the sediments which are dredged for navigation purposes along the Danube floodplain, and of course the sediments from the Sulina Bar dredging, which are lost to the sea, and we need it to be used by the littoral currents to be redistributed like in a natural landscape for reducing the coastal erosion. The other solution that we advocate for, it is the sediment redistribution using the existing channel network to bring useful sediments to the critical sectors from the delta plain which are the most affected by the lowering compaction and subsidence, and will be the most impacted to the drowning. So these are the two solutions, one based on the sediment redistribution on the coast and the other within the delta plain.
In conclusion, what would you like people to keep in mind about your project?
A wider perspective than exactly our project, because our species, Homo sapiens, appeared and evolved on the Earth only in relation with the climate changes. The climatic crisis allowed the appearance of the species, and the most important moments in its evolution, for instance, the Neolithic appearance, not coincided but was induced by the Holocene climate, which was very stable and much more better for developing sedentary settlements, or the big cities appeared when the sea level stabilized, like around 5,000 years ago, or the Bronze Age fall decline was also related by the drafts in the Europe and so on. So this is already proven that the major changes for the human societies, and sincerely for every animal species, are related by climate changes. This is not a story, it's the real truth. And I think we need an in-depth knowledge of what happened, of what happens, and to have better and better future projection in order to adapt as clever as possible and to become friends with these changes, because it's the only way to survive and to remain in a, let's say, positive and stable state on the Earth for us.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the Norway Grants research program by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is a key to a better future.